What if for this example I wanted to write the power series for this f of x? Now again, I see a fraction, and when you see a fraction like this that looks something like the sum of a geometric a sub 1 over 1 minus r, you try to make it that way because it's actually a very simple thing to do, like to work with geometric as opposed to working with the ratio test. So since I have a fraction and this is a fraction, I'm going to try to make it match up. Now, this 1 is very important. My denominator has to start with a 1. So what some people do is actually that's what they adjust first, and they'll say, okay, I need this to be a 1, so what I'm going to do to make that a 1 is divide everything by 4. And as long as you do it to everything, you're fine. And what you're really doing is multiplying by a very clever form of 1, like 1/4 over 1/4. Since it's the same numerator and denominator, you're multiplying by 1, you're not changing the value. So if I do that, I have f of x equals 1/4 divided by 1/4 distributed in is 1 plus, and I'm going to write it as an x over 4. So I'm a little bit closer. I have a 1. The only other issue I have is that this is a subtraction symbol and I have addition here, but that's actually very easy to fix. I'm going to say f of x equals 1/4 over 1. Then I'm going to change it to a minus, and I'm going to put a negative here, x over 4. Because when you subtract a negative, you're really adding. So this f of x is equivalent to this f of x, but now it's matching the form a sub 1 over 1 minus r. So since it is, I know that I can write it as a geometric. A sub 1 will equal 1/4. And my r, my common ratio, will equal a negative x over 4. So if I write out my series, my first term is 1/4, then I'm going to multiply by a negative x over 4. So minus x over 16, then it times another x over 4, so plus x squared, and then 16 times 4 is 64. I need one more, so times another negative x over 4, so minus x cubed over, and then 64 times 4 is 256. Those are my first 4 terms plus my ellipses equals, and then this will be the sum from n equals 0 to infinity, and I'm going to take a look at what's happening. If you take a look at this, we know that this is alternating. We have positive, negative, so I can put a negative 1 in, but you can also remember that this is just geometric. So you can take it apart, look at your numerator, look at your denominator, or say, this is geometric, here's my common ratio, my negative x over 4. I multiplied it multiple times, so in this I'm going to have a negative x over 4 and figure out what's happening to my n and how I need to adjust it. So if I put it to the n right now, at n equals 0, this is all equal to 1. But my 0th term is actually 1/4. So I can do 1 times 1/4. Now I'm going to try it for n equals 1. So I have my 1/4 times negative x over 4 to the first, which is just negative x over 4, and that is negative x over 16. There it is. When I plug in n equals 2, I'm squaring this times 1/4, and I have my next term. So this could be seen as my sum of the series, and it is. There are different things you can do with this, but this one's fine. And then I want to know when it converges. Well, I know that this will converge when the absolute value of my r is less than 1. So what I can do with this is the absolute value doesn't really need to be on the 4. And the absolute value of negative x, we're just having a positive x here. It's the same thing as the absolute value of positive x. So we would have this over 4 is less than 1. Now I'm going to multiply both sides by 4. The absolute value of x is less than 4. And then I know that this is the distance from 0. So again, if you look on a number line, here's 0. I can go out 4 in either direction, and my x has to be in this interval. So it converges on the interval from -4 less than x less than 4. So the function will match in this interval, but not match in the other two.